Okay, guys, I'm going to roll through a student's work here. I do have a student that got 25 of 25, so I don't get tripped up. But I'm going to roll through the questions, make sure we understand different things. So here I have a box and whisker chart of snowfall for 14 cities. The median amount of snow that fell, well, I got to know this is the minimum here, first quartile, median, quartile 3, and maximum. So the quartile 3 is 64 inches. That's just the anatomy and understanding what a box and whisker chart represents. Box and whisker chart, I'm concerned that is the exact same question. That is also 64 inches. Did the same question go on there twice, apparently? So you got double dinged if you missed that one. Whoops. I'll make sure that doesn't happen. Consider the box below. What is the lowest quartile, or the lower quartile? That would be referring to quartile 1 here, and that's the left edge. So minimum, quartile 1, median, quartile 3, maximum. So that's referring to quartile 1. 3, you could make a little bit of an argument because that is technically quartile 0 if you're advanced mathematically. So if somebody wants to make that argument, you bring it to me. All right. The interquartile range, that's certainly from Q1 to Q3. So that looks like 10 minus 6.5, because that's this line's a little bit over, but it's not quite to 7. So 10 minus 6.5 is 3.5. When using IQR to find outliers, what formula is used to identify the lower limit? Well, it's 1.5 times the IQR subtracted from quartile 1. So I take 1.5 times the IQR and I move to the left of quartile 1. So the formula would be Q1 minus 1.5 times the interquartile range. When using the IQR to find outliers, which formula would identify the upper limit? Well, that's going to be the 1.5 times the IQR plus, or added on to Q3. So Q3 plus that extends my fences out to describe the outliers. What percentage of data is between 40 and 90? So 40 is the minimum, 90 is the first quartile. So 25% of my data falls between here and here, 40 to 90. 25% of my data would then fall between 90 and 100. 25% of my data goes between 100 and 140. And between 140 and 150 is 25% of the data. But it breaks it up into 1/4. Identify the outlier for the given data. Okay. So that would be a little bit tricky. I'd actually have to limit them. I can do it visually and say it's 7, but I would actually probably write them out. 7, then 23, then 26, then 27. I'd do that. I'd actually put it into a box and whisker chart and calculate the fences to be sure, but certainly the answer would either be 7 or there is no outlier in this data set. In order to do that, I'd have to jot those out, set up a box and whisker, and calculate my fences to be sure. Nashville or Dallas, which one has a smaller median? Nashville is a smaller median. Nashville looks like 50, and Dallas looks like about 57.5. That's just understanding what the median is. Which of the numbers is not part of 5-number summary used to create a box plot? Okay, so a mean does not actually have to exist there. If you watch my video on creating a box plot of the box plot quizzes, the mean is not 100% necessary. I always put it on there afterwards because it's a useful piece of information. But what actually defines my quartiles is the minimum, the maximum, the first and third quartiles. That's what divides it into 4ths. Which statement is true? When I start looking at this, so this is truly an interpretation of this, male and female. So it is unusual for male actors over 50. Well, no, because over 50, you are still in the interquartile range. Females actors over 60. Oh boy, that's female over 60. That is very unusual. That would be, I believe, an outlier. Certainly outside of the maximum ever won. That says a lot about sexual stereotypes and sexual dynamics in our society. And then if you look through, that certainly is gosh, that's striking. I might boycott the Oscars next year. All right. Find the quartile 1, quartile 2, quartile 3 IQR and range of the given get data. So certainly I'd write this out, and in order to do that, I would write it out. And let's see, they did a nice job putting it in order. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So each one of them would have 4 1/4. So instantly I can start coming over here. Each one would have 3 1/4. So that's what gives me 12.5 for my first quartile. My first quartile would be there. The median would be 1, 2, 3. It would be half of 15. And at that point, I can rule them out because quartile, the only other one that has the first quartile correct, and then quartile 2 or median is the median's wrong. So this is the only one that meets that. But bottom line is I'd put some paper on that. I'd write that out, put my box and whiskers on it, and then see where the numbers fall. True or false, 75% of the data values are greater than 18. All right, that's false. This is 1/4 of the data goes from 4 to 16. So 75% of the data is greater than 16. That would be this box, and this box, if you think in terms of fourths. But if I put it right here, that is not correct. And it does a nice job of saying false. The value is greater than 16, 75%. Next one, data set 5, 6, 7, 8, 9. Okay, represents the number of hours spent on the internet in a week by students in a mathematical class. Which box and whisker plot represents the data? Okay, so I know I'm going to go from 5 to 19. So this one is out. Number 1's out because that goes from 2 to 19. The rest of them all start at 5, and then did they all end at 19? Yes, that is true. Okay, so I'm going to look at the differentiation here. What I'm going to do is I'm going to do the median because they all have different medians. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So at 7.5 is going to be my median. So 1, 2, 3, 4, 5, 6, 7, 1/2. So 10 would be my median. That way I'd have 7.5 above and 7.5 below. So which one has 10 as my median? This one right here. So number 2 must be the correct answer. Number 2. Which profession had the greatest range of salaries? The greatest range, that just simply means from minimum to maximum. Musician has the greatest range of salaries. Which has a larger IQR? Interquartile range, that's the distance between Q1 and Q3. So this one has a larger interquartile range. Here it's 0.75 to 1.25, which is 0.5 for this one. Here it goes 1 to 2. So this one has twice as large of an interquartile range. So Stephen has the larger interquartile range. That would be the width of the box. Find the median of the data set. Okay, at least they put it in there. So I'm going to count the number that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 9 on the left of the median, 9 on the right. That puts me a vertical line right here between 85 and 87. So the middle of that is 86. And you can see the answer is 86. Mean of this data set, I'm going to have to count up how many pieces of information I got again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Same thing. We're going to go to 9. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh my. Mr. Spurgeon made a terrible error. I apologize. I read mean and thought median. So the mean of this set would simply be the mean average of all these, meaning I would add them up and divide by 18, because there's 18 numbers. Add them all up, divide by 18, I get 82. Oh, I would have missed that one. Mode. The mode is the most common occurring one. Let's see, there's 2 77s, but there is 3 88s, so 88 is my mode. Hopefully that would have jogged me to go back and look and realize they were playing around with the averages, which is not the middle 50% of data value, not in the middle 50% of data values, so the middle 50% of the data values are in this box, so 12 to 22. Which one of those numbers does not fall between 12 and 22? That is 11. If 44 values were used for the data, and about how many data values are greater than the first quartile? 33. The first quartile is right here. So 75%, or 3/4 of 44, is 33. It's not about how many, it's exactly how many. 33. Which value is in the top 25% of the data? That means that exists over here. So anything greater than 28 would be greater than the in the top 25. So technically, I hope if you answered 29, you have an argument that's also correct. 36 is the highest value, but 29 is also in the top 25% because it is in the quartile that rests between Q3 and max. So if you missed that wrong, make sure to tell me and I'll mark it. Find the median of plot B. All right, median of plot B. That's over here. The median would be 30. So here's plot A, here's plot B. The median is that right there. That is 30. Getting towards the end here. If plot B has 60 numbers in it, how many are in the box? 30. Because the box has half the data. 25% here, 25% here. That's 50%. 50% of 60 numbers is 30. All right. Guys, feel free to ask me questions if you need me to write some stuff out. I'll glad to do that in class anytime, okay? So please go over, take a look at what you didn't understand, and we can, let's move to the right. Let's move the box to the right and jump into the next quartile if you can. Good luck on Wednesday's quiz.